The trapezoidal rule is practically an approximation from the area between A to B. F is continuous. Let's say you have a curve, and under a curve you can separate each part into different intervals, from x of 0 which equaling A, which is the first, to x of n equaling B, which is the end. Right here, this portion just describes that x of 0 is less than x of 1, x of 1 is less than x of 2, and it continues like that until you reach the final one, which is x of n equals B. Right here, it states the distance between the change of intervals, so delta x equals b minus a over n is just the distance from x of 0 to x of 1, from x of 1 to x of 2. It stays the same because each distance has to be exactly the same length.
So in the trapezoidal rule, in order to obtain the area underneath, we're going to take it one trapezoid by one. However many trapezoids you need, I'll explain it right now. So in this, our height is b minus a divided by n. And we're taking our first trapezoid, which will be from x of 0 to x of 1. And then f of x0 is our first base, which is also equal to f of xi minus 1. And then f of x1 is our second base, which is also f of xi. So knowing this, we can rewrite it with knowing the area of a trapezoid to be base 1 plus base 2 times the height divided by 2. So we'll rewrite it as f of xi minus 1 plus f of xi divided by 2 times the height, which is b minus a divided by n. So now, knowing this, and we have one trapezoid here having this formula, but since we have multiples, we would write them all in here. So you're going to have your first trapezoid plus your second plus your third, so on until you get to your very last one. Now on this side, they're all being divided by 2. So we can factor out a 1/2 from that whole side, and it turns into 1/2 times b minus a divided by n, and what we're left with is f of x0 plus f of x1 plus f of x1 plus f of x2 plus f of x2, so on until you get to f of xn minus 1 plus f of xn. Now, you combine these two together and you get b minus a divided by 2n, and then on this side, since you have two x of 1s and then two f of x2s, you can combine those and you'll have f of x0 plus 2 times f of x1 plus 2 times f of x2, so on, plus 2 times f of xn minus 1 plus f of xn. Now in the trapezoidal rule, the first and last term do not get multiplied by 2. Only everything else in the middle gets multiplied by 2.
So the equation we chose to use was the integral of the square root of x cosine x dx. And this is how the graph looks. And first we'll start off by using the formula, which would be b minus a over 2n and all that. And what we're looking for is the approximate area from 0 to 1. And it will be split up into 5 intervals of 0.2. So after the 0.2, it'll be 0.4 and so on. And in the trapezoidal rule, the first and the last term does not get multiplied by 2, which explains why this is multiplied by 0 and this is 1. And the rest doesn't have the intervals in it. And since we did each, which would be 0.2, 0.4, 0.6, 0.8, these are the answers that we came out with. Our b would be 1, and our a would be 0, and our n would be 5. And we plug it into the equation. So like I said before, the equation would be b minus a, so it'll be 1 minus 0 over 2 times our n, which is 5, which gave us 0.5107, and that's our approximation. But with the calculator, we got 5.31, which ours was 96% correct. And in order for us to find that, you just divide our approximation by the actual answer, and then you multiply that by 100, and that gives you 96, and our error chances were 40%.